Hey everyone, welcome to Code Harmony. Today we are going to solve this question 2999. Count the number of powerful integers. This question has been asked in companies like Hashtin, Sprinkler. It's marked as hard. It's hard because of the constraints. Otherwise, it is very easy to implement. Let's have a look at the problem statement. Here we are given three integers: start, finish, and limit. And we are also given a zero index string s representing a positive integer. A string is also given to us, and they are saying that a positive integer x is called powerful if it ends with s. It means s is a suffix of the given integer, the powerful integer, and each digit in this powerful integer at most limit. So the digit value should be less than equal to limit. So limit is from 1 to 9. If the limit is 4, every digit should be less than equal to 4. Then return the total number of powerful integer in the range. So starting with start and ending with finish, we have to return all the integers which are powerful. And for the powerful integer, we have two conditions: ends with s, and the digit should not cross limit. A string x is a suffix of y. Okay, that's just the definition of suffix. Let's try to understand it with the help of an example. Here, the start value is given to us, and finish value is also given to us. We have to figure out all the powerful integer in this range, both inclusive, starting greater than equal to 1 and less than equal to 6000, and two conditions are given to us. Digit, every digit should be less than this limit. None of the digits should cross 4, and the suffix is 1 to 4. So from starting from 1, the values should be something like this: 1 to 4. Suffix is 1 to 4. And then 1 1 2 4, this is also having suffix 1 to 4, and the digit is not crossing 4. Then I can take 2 1 to 4. Here also the suffix is 1 to 4, and the number is not crossing any digit which is crossing the limit. What else can we have? 3 1 to 4, 4 1 to 4. That's all we can have. If I just want to take 4 1 to 4, suffix is same, but the limit is not matching. Limit is crossing our desired limit, so we are not going to consider this number. So these are our numbers and a total number of powerful integer. So this is something we have to return: 1 2 3 4 5. We have to return 5 from our problem. So this is our problem statement. Every powerful integer should have a suffix which is given to us, and every digit in that powerful integer should not cross this limit. In short, if I just try to give a brief idea how we can achieve it, one thing that is coming to my mind is that just directly count the number of powerful integers in this range. What we can do is start the iteration from start. Let's say I is equal to start, and then go till finish. And at every step, you have to check the validation of a powerful integer, which is like if it is following these two conditions. So iteration is something I'm suggesting to you use, and in the iteration we can start our iteration from start and go till finish, and we can check these two conditions. The current element is ending with the suffix s. Like current number, let's say current number is 2124. 2124 is ending with 1 to 4. This is something we can check, and each digit is less than equal to the limit. So each digit in this should be less than equal to limit. So this is something we have to check. Like if I just convert the number into the string and just check if the string ends with this number, then it is yes. And if in this string every digit, how do we get the digit? Just get all the digits one by one using the modulo operator. Modulo with 10, we got the last rightmost digit, and then divide equal to 10. We just remove that digit. So using that value, we can check the digit as well. So using the iteration, we can do that. So for every number in this range, so if I just try to write the code, I is equal to start, and I less than equal to finish. Now I have this number, ith number. What I have to check is if I ends with suffix and valid digits in I. It means all the digits are greater than or equal to the limit. If that is the case, just answer ++ and we'll get our answer. So this is something I did one iteration, let's say order of n time I'm doing the iteration, and after that I'm checking this condition. Let's say the any element any number is of the length n, so it will be something like this, n into L. And what about the validity? Validity is the same thing, validity n ends with n. So let's say this is covered in this L. L is the length of that current number. So here this is the case. And how we can improve it? We are starting with start and ending with finish, and then going and checking every single element for S as a suffix and validity as I. So in this case the time complexity will be order of n into L is the time. But here if I just check the constraints, in the constraints the value of n is going till 10⁻15. 10⁻15 this which is definitely going to give us time limit exceeded. So we can't just go ahead with this brute force solution. Here to optimize this what I can do, let's take the same example. If my start is 1 and finish is let's say 1000 and limit is 5 and suffix is 25. If suffix is 25, we are definitely going to start with 25. Okay, 25 is my first powerful number if it is in the range. Then after 25, what is the next powerful number? Definitely whatever is the next number, we are going to have a suffix as 25, and as the left of it the minimum we can have is 1, right? And what is the next number? The minimum number next to it can be 2 to 5, it can be 3 to 5, and so on, if that is within the range. First number is 25 is, let's say 25 is my current number, let's say I is 25, I is equal to 25, and after I, what I can see is that I am adding 100 into this, and then I am again adding 100 into this, again I am adding 100 into this. So instead of running the loop, incrementing it by 1, I ++, instead of going it one by one, doing the iteration from start to end, why not we just directly jump over the next number by adding this base value? And what is this base value? This base value is definitely whatever is the number of digits, or you can say s dot length. Whatever is the s dot length, 10⁻that, 10⁻10 into 2, 10⁻2 for 25. Why? Because there were 2 digits. Digit 1 is 2, digit 2 is 5. 2 digit, so 10⁻2 can be our base value. It means incremental value. Otherwise in the default iteration we do the incrementation by 1. Instead by 1, why just do it by 100? Because in this case the suffix will remain same and this value will get incremented one by one. This value of the left side, which you can call prefix is getting incremented by 1. Prefix is getting incremented by 1, by 2, by 3, and so on. So okay, so here what we have decided is that we can take some base value which is 10⁻s dot length. Let's say s dot length is L. If the s dot length is L, then our loop in the worst case will not go till 10⁻15. It will go till 10⁻15 minus L. And if we have sufficient value of suffix, let's say suffix is of length 7, then it will be 10⁻8, where we can easily submit it over the LeetCode. But this is for only if the suffix value is larger. If it is not larger, then we can't do it. So here, if I just try to optimize this brute force, I can go something like this. For I is equal to start, definitely we have to go with start. I less than equal to finish. Starting to finish I have to go, and then I plus equal to power of 10 raised to power s dot length. This is my base value. So every time I am incrementing, if my s value is 25, I am incrementing by 10 power 2 every time, and my loop will be efficient in this case. So here we don't have to check whether that is having a suffix of s or not. So this condition is also we are able to avoid now. If every time we are definitely maintaining the suffix, then there is no need to check whether the current number is having the suffix or not. So just we avoided this condition, but valid digit is something we have to use. If valid digits of I, if I is having the valid digit, then answer plus plus, answer plus plus, otherwise just keep moving further. So this is our code. Hard problem, but the code with 2 statements. So here we maintain the base, and we are maintaining valid digits. So let's say the length of the condition is L. How do we make sure that okay, in this L size string or number we are having every digit greater than equal to limit? Let's say the value of L is 2225. To check if every value is greater than equal to limit, just take modulus with 10. If I take modulus with 10, I get rightmost digit. Rightmost digit is 5. I can check whether it is greater than equal to limit. And let's say if the limit is 6, so I can check if the rightmost digit is greater than equal to limit. So let me directly write the valid function. Valid num, and while num is greater than 0, just get the digit is equal to num modulo 10, and then you just check if digit is crossing the limit. If digit is crossing the limit, directly return false. Otherwise, if we are not able to cross the limit, that will return true. And after the digit count, just reduce the value of num as well. Otherwise we'll be falling into the infinite loop. So this is my utility function, and this is my main function. And now just try to implement it. And what is the time and space complexity of this? Time complexity is something order of n raised to power 15 minus L. And you can also multiply the size of this L, order of L size, to check the number of digits. Order of 10 power 5, n raised to power 15 into L. Here if we are having sufficient value of L, if suffix is of enough length to make it reduced version, maybe till 10 power 8, then we are good. Otherwise we have the only option, right? We'll definitely get TLE. Now let's try to see if we are able to submit this code or not. Let's have a look at the code that of the approach that we have just discussed. Here I have written the code where my iteration will be starting from the starting suffix and going till the finish, but not just appending one by one. I will just do the loop where every time I am jumping by the base value. Because see, let's say if the suffix is 25, there is no need to check 26, 27, 28. Directly check 125 and directly checked 225, and we just have to make sure that these values are within the range. See, definitely we have a condition that this number is not crossing finish, but we have to make sure that number should start from this start, because there might be thing that suffix is 25 and the start is 200 and end is 500. So in this case I have put this condition. So what is the starting value is? Starting value is this string. The string is 25, maybe this 25 I am converting it to long value, and I will just increment this value every time by base, and base is 10 raised to power number of digit in this string. So this for loop we are going to run, and this num greater than equal to start condition we are going to put, and the second condition is all digit less than equal to limit. This is a utility function I have written, just checking the digit in the given number, and if that digit is crossing the limit, just return false. Otherwise just move ahead and return true. So this is our function, and it is running fine on the sample test cases. But when I submit the problem, it is giving me TLE. Why? Because when the suffix is very small and the range is bigger, so the time complexity of our approach was order of n raised to power 15 minus L into L. This L is not too large, L is 2, so it is going till 10 power 13, 10 power n raised to power 13, so which is also going to give us TLE. So in this case we can't just go like this. We have to generate our number keeping the digit in the within limit. Let's have a look on that approach now. So now we'll be coming to our approach 2, and approach 2 will be named as digit DP. You might not have heard about it, but let me tell you what is this. See, sometimes where problems are related to some ranges that we are starting from L and going till R, and you have to pick the items, pick the numbers based on some conditions, certain properties. Let's say in this case, if I just give you an example, I tell you that you are given a range left to right, starting with left and going till right, and the condition is there no digit in the number should be greater than 5, and the number should end with this suffix 25. So let's say that L is equal to 1, R is equal to 100, and the suffix is 25. So I should have numbers like 25, 125 I can't have in this range. So there is only one number, which is 25, and they can request us anything like sum of all of those numbers, count of all of those numbers. This problem itself is the same problem, count of all of those numbers with the digit not crossing the limit, and it is ending with 25. So this problem is related to our digit DP approach. And here, what is the main idea behind this? The main idea is that what we did in our previous example, that we iterated over every single valid number. So starting with 25, I just directly jump to 125, then 225. So instead of not going linear fashion, this linear fashion is going to give us a time complexity of n raised to power 15 minus L. But still, if the L value is less, I'm not going to get a good answer, or my problem won't be submitted on LeetCode. So this should be in a valid limit range. So this is the idea behind this digit DP, and the main intuition is that we have to avoid checking every number. See the similar kind of thing, that avoid iteration. So we have to avoid iteration, and whatever is our limit, let's say 0, 1, 2, 3. If the limit is 4, it should be less than equal to 4. So use all of these numbers and try to generate the number. Let me show you the steps. What are the steps? First of all, the suffix is fixed. Let's say the number is number range is 1, and it is going till 1000, and the valid suffix is 125. We can directly fix the suffix 125. And what is the size of this finish range? 1, 2, 3, 4. 4. It means this suffix is fixed, and add this number we have to add digits, right? Recursively add all the digits in this using digit DP. And how we can add this? We just have to check the limit. What is the limit? Limit is, let's say, 5 in this case. So we can add digits like 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, add this. Just firstly add 0. It will become 0 and 125. 1 and 125. 2 and 125. 4 and 125, like this. And also 5 and 125. So it is 1000. Let me just take it 2000 because I'm getting only one answer. Okay, let's say the range is, let me show you again. Start is 1 and finish is 5000, and the suffix should be 125, and the limit is 4. If the limit is 4, no digit is crossing the limit. Suffix is 125, then there is no need to calculate the suffix. Whatever answer we are going to get, we should have suffix at the end. And if it means 3 digits are already filled, maximum we can go till 4 digit. So just add one more space here and add this space. Just try to keep adding digits from this limit. Limit is 4, 0, 1, 2, 3, 4. So firstly add 0 here, then 1 here, then 2 here, then 3 here, then 4 here. If I add 0, it is within the limit. If I add 1, 1125 within the limit. 2125 within the limit, within the limit, within the limit. Right? So this is how you can check. And let's say if I just increase the limit of start 1000 to 5000. In this case, when you are adding 0 to this, it is becoming 0, 1, 2, 5. It is not within the range. So just don't include it. Whenever the number is having all the digit, and to check the digit, we can directly check valid function. Not the valid function, I think digit is already something we are adding. So we don't have to validate the digit. So digit is always valid. We just have to check whether the number is in the range. Less than equal to finish, greater than equal to starting. So this condition we have to check for every single generated value. And this generation you can do by recursion. First of all, add 0 into this, 1 into this, 2 into this, 3 into this, 4 into this. In short, what you can generate is, ignore this suffix. Finish is of length 4. Suffix is of length 3. It means only one length element you have to generate using some certain set of digits. You have one space and you have some digits 0, 1, 2, 3, 4. So this is something you have to do. Or once it is generated, if it is generated, it means the length of the temporary string is equal to 1. Then just capture it if it is following the condition. Right? So this is our digit DP approach. I'm not going to I've just gave you a brief basic idea of this of the digit DP, so that you just get some easy or medium level problem, you will be able to figure it out. The main idea is the recursion, and in the end just try to save time using memorization. So first step is fixing the suffix that we understood that okay, prefix, whatever is the prefix we require, let's say we require prefix of size 2. Just try to create prefix using those limit range 1, 2, 3, 4. If limit is 3. Then recursively count all the digit, and then we have to make sure this validity we have to check. It is between start to end. And after that, see if you can memorize the call or not. How you can memorize the call? Let's say you are creating a DFS function and you are returning maybe let's say prefix. Let's say you are writing a DFS function and you are passing n, and what you are returning is returning all the valid number till this range. All the valid number till this range. Let's say my range is from left to right, and I call my DFS function and I tell my DFS function that your responsibility is to return all the valid number till r. So DFS returning all the valid number till r. If I subtract all the valid number till n minus 1, then I will get my desired answer. Right? And this function might call some other values, might call some other subproblem, then those are going to be overlapped. So in short, this DFS is taking a number n and returning integer. So taking a value and returning a value, these values you try to cache to save time using memorization. Now let's directly write, have a look on the code. I'm not going to write the code. So here this is the code of this problem where I have used digit DP approach, because my previous approach is not going to give me the enough performance for very large input size till 10 to the power 15. So in digit DP we are not going in iterative fashion. Instead we will be generating every single number by appending a digit which are valid for that number. See, we are having limit. So let's say if the limit is 4, we can only choose a digit which are 0, 1, 2, 3, 4. And what utility function I have created is that count all the valid number till this range. count all the valid number till this range using these digits and fixing this suffix. This is a suffix. So just prepare, let's say the suffix is 25, and prepare the prefix. Let's say the limit is starting is equal to 1000 and ending is equal to 5000. So we can have digits something like, let's create 4-digit element. 1, 2, 25 is fixed. So in this case, I just need a prefix of size 2, right? And that 2 size prefix can go from 00 to limit is 4, then 44. So this is something I'm generating a prefix, generating all the valid number which is having a range less than this finish, and using this limits. So this is going to give me all the numbers, but it might give me the numbers which are less than this size. So for that, I have used this trick that count the number starting till start -1. So we just have to subtract those numbers. So this is something I'm writing using recursion. Here, this is my count up to function, which is actually counting all the valid numbers, and for that it is calling this DFS function, which recursively generating every single valid number, and if it is generated successfully, returning 1, otherwise returning 0. And at the end, we are doing the memorization as well, memorizing all of these elements. And we can memorize on the basis of I only, index only. So it's a linear memorization, saving time. Let me submit the code. I'm going to attach the code in the description below. You can just have a look and try to understand if everything's working fine. Otherwise, do let me know in the comment section below. Thank you guys. Bye bye.